Okay. So as you can see here that again I have created a data frame for the same purpose. So just let me run this part and you can see it's something like exactly the same data frame. It is reflecting what I was discussing in my previous time. So now what I have written the code for different type of encodings. For example, label encoding using the label encoder class, just what basically we have discussed in my lecture, that as you can see here, this hot is represented by 1, cold is represented by 0, very hot is represented by 2. So each and every temperature category has some corresponding numerical value. That is true, but the problem that already you have observed, I hope, that is, you cannot relate the features, the value of the features. I mean, for example, one definitely lesser than very hot, one should be less than very hot, by its nature, but numerically it is not represented because one corresponding value is given as 3 and very hot's corresponding numerical value as 2, which should not be the ideal case. Anyway, so in a similar way, we can go by this particular technique as well, which is representing almost similar one, but maybe you see you are not getting the exact distribution over here using label encoder and pd dot factorize. You are getting different distribution, but the problem is not yet solved. So that's why you can go for ordinal encoding, where you can use a dictionary to create what exactly numerical value you should have for these different features, sorry, different categories. So if you want to apply this ordinal encoding, the first thing that you have to know is that set of discrete features, sorry, set of discrete categories present in that particular feature. Until and unless you don't know how many categories are there in that particular feature, it is not possible to create this dictionary, right? And until and unless you create this dictionary properly, you cannot apply this map function. So this is a criteria to use this ordinal encoding function, ordinal encoding technique. That is, you have to closely watch that particular feature whose numerical representation you want to find out, and you have to find how many individual categories are there. Now let's move forward again, go for binary encoding, as already you have seen in my previous lecture. That is, I'm sorry, no module category encoders. Okay, there is some issue, I think. Okay, I have to check it. Anyway, so already you have seen that how binary encoding was, so I'm not going in detail of this. And similarly, you can go for one hot encoding as well. That is, you see it's representing temp cold, temp hot, temp very hot, temp warm. These four different features, sorry, four different column is created because you have four different categories. If you have five different categories, then naturally five different column will be created. But there is a trick here that I will explain it in a bit detail later. Just for timing, I'm showing you here that you see. Remember always that if you have four categories, okay, and you want to represent by some one hot encoding technique, three columns are sufficient. What I mean to say is that if you have a n categories in a feature, and if you want to represent that feature into some one hot encoding technique, then n minus column is sufficient to represent the n categories in the feature. Why I am saying n minus 1? Why not n? According to present situation, it is n, because there are four categories and you have seen four columns are there, right, which represents four categories, but four columns are not needed. you can do the same thing using three columns as well. Why it is three and how we can do this, that I will maybe I will take a bit, I will take another class, a short class to explain why it is three, why n minus 1 is sufficient. So anyway, so let's do one thing, let's move forward. So basically what we have completed till now, that is we have seen what are the different type of encoding techniques, right? So in the data processing part, with respect to, if you say, because we started from the data processing long back, so if you go back, let's do one thing, let's see what we have learned.